Good morning, good afternoon, everyone. Today we will have our week 15 live consultation hour for NGEC 9, and right now I'm still waiting for students to come inside the room or the stream, and right now I have one viewer. I'm still waiting for others to come in. Test. Right now we have 2 viewers. I'm still waiting for the others to come in. Please type your name in the comment section below so that I would know who's in or who's watching this live stream right now. Uh, right now we have 3 viewers. Please type in your name in the comment section below so that I would know who's present in this live stream. Good afternoon, Mr. Papiona. Right now we have 5 viewers. I will start my discussion in about 3 minutes. So 3 minutes from now, I will start discussing the example that I have told you yesterday. Good afternoon, Mr. Puerin. We will start in 2 minutes. We now have 4 viewers currently watching this live stream. We now have 3 viewers currently watching this live stream. Again, please type your name in the comment section below so that I may know who's watching this live stream. I will be starting my discussion in 1 minute. So I'll start. Good afternoon. Welcome to this week's live consultation hour. I will solve an example of for CO3. Write spherical triangle. So, as a review, as I have discussed yesterday, a spherical triangle is a triangle formed or created by in a surface of a sphere, and it is created by the intersection of three great circles, as we can see in this illustration taken from Wikipedia. This is an illustration of a sphere with three great circles, or a circle that passes through the center of that sphere. Let me put a dot on the center. So at the center of the sphere, each of those circles passes through that point, or it hits that point at the centermost part of the sphere. For example, if you take let's say that's a ball, and you take a knife and you slice that ball. If you slice that ball, if you take the knife and slice that ball this way, you will pass through the center point. So in another orientation, if you slice the ball in half this way, it will still pass through that center point. And for the third great circle, if you slice the ball this way, it will still pass through that center point. So if the circle intersects or passes through that center point of the sphere, that is what we call a great circle. If we slice a ball right here, that wouldn't be a great circle, because it wouldn't pass through the center point. It will only create a small piece of that sphere, and it didn't pass through the center point, so we cannot call that as a great circle. This is not a great circle. So if we look at this illustration, we have a triangle formed, this triangle, for example. So it's like a curved triangle. It's not a plane triangle, wherein a plane triangle is a flat triangle. This is a spherical triangle. It curves according to the surface of the sphere. So if you can remember, in a plane triangle, you have three interior angles. One, two, three, and you also have three sides. One, two, three. So in a plane triangle, you have three internal angles and three length of the sides. For a spherical triangle, you have the same three length of sides, and you also have 3 internal internal angles. So you have a maximum of 6 parts, 3 sides, and 3 internal angles. One thing that you should note when dealing with spherical triangle is the sides are measured in degrees as well as the angles. Why are the side degrees? Because if you are in the center of the sphere, if you are right here, center of the sphere, so for example, we have angle B, we have angle, or the angle of side B, we can see that the length of side B corresponds to the angle of B at the center point. So if we say, if for instance, if B is a small angle, then the corresponding distance at the surface of the sphere is also a shorter distance. On the contrary, if your angle is larger, for example like that, then the corresponding distance at the surface of the sphere is longer. So that's why the measure of the sides are given in degrees. The answer for B is, the unit is in degrees, as well as A and C, because those are angles, and the length of the sides are also given in degrees. And then you have to convert those into km, kilometers, or nm, nautical miles, with the right spherical triangle. I have defined what a spherical triangle is. Now I will define what a right spherical triangle is. A right spherical triangle has an internal angle of 90 degrees. Only one of the internal angles is 90. Take note that for a spherical triangle, it's possible that 2 angles are 90. It's also possible that 3 angles are 90. So if there are 2 or 3 90-degree angles, then that is not considered as right. So to consider a spherical triangle as a right spherical triangle, it should only have one 90-degree internal angle. So for example, if angle A is 90, then angle C and angle B should not be 90 for it to be considered as a right spherical triangle. So only one angle should be 90 degrees. Only one internal angle. If you can remember, in your plane triangle, in right plane triangle, it's impossible to have 2 90-degree angle, because the total of internal angles in a plane right triangle is 180, or any triangle is 180. So if you have 90 here, so it would be impossible to have another 90, because then you will be left with 0 on the third angle, and that's impossible. For a spherical triangle, it's possible to have 2 90 or even 3 90-degree angles, because the triangle is curved, so the angles are more, it's like it's more split the opening is wider, so it's possible to have multiple 90-degree angles. It's possible that, for example, angle B is 90, angle A is 90, angle C is 90. That's possible for a spherical triangle. So again, if in a spherical triangle, there should be only one 90-degree angle for it to be considered as than one. If there are three or two, then that is an